Welcome back, students. So our next topic is data independency. Let's see what do you mean by data independency. So data independency means what? It is a capacity of changing the schema at one level without affecting the data. That means if you change any level of the data, it doesn't affect other level. Okay, so that's why they called independence data, not dependence. Okay, to make that, it will use that database in a multi-layer. If that data is in a multi-layer, then not a single layer will affect to the another layer. That means it called independent. Means suppose this is one layer, this is one layer is there. If we change this layer, so it doesn't affect this layer. Okay, but there is a mapping between these two layers. Okay, both the layers are independent. That's why it is called data independent. Okay, so why we require this? Database should be in a multi-layer. if if sorry if that database is not in a multi-layer, it is difficult to change the database. So that database should be designed in the multi-layer. First point is what? That database system are designed in multi-layer. Okay, if it is in a multi-layer, so it is easy to make a changes in one particular layer. Okay, if you make the changes in one layer, it does not affect to the another layer. Okay, next thing is what? The database system stores data about the data. Whatever the database system is there, it stores the data about the data, that known as the metadata. Okay, now that database system stores data about data, that known as what? Metadata. Now what do you mean by metadata? It stores data about the data. Metadata working of the metadata is what? It is to allocate that data to retrieve it easily. Okay, to retrieve that easily, what we need? We need multi-layer architecture. So whenever the metadata is created, it allows, or it always follow the multi-layer or layer architecture. Okay, so why we need the layer architecture? As I told you, to work in an independent way. So metadata also always follow the rules of a multi-layer architecture. Next is what? If they are independent, then also there is mapping between that layers. Mapping between the layers. In layers, even though they are independent, but there is some mapping between there. Okay, understood why we need data independence? Okay, if we change, or sorry, if you change any level of the data, it don't affect the other level. That's why it calls that independence. It's not dependent on any layers. Okay, so why we require? We require it if that database is not in a multi-layer, so it is difficult to changes, to do the changes in that database. Okay, so we need that database must be in a multi-layer. So database system are designed in the multi-layer only. Okay, if it is in multi-layer, it is independent. Second is what? The database system store data about the data. If that database system store data about the data, it's known as a metadata, and metadata is also going to follow the rules of the multi-layer, or it's always in a layer architecture. If it is dependent also, if it is independent also, then also there is a mapping between the layer. Okay, understood? Next is what? Types of data independence. So there is two types of data independence, that is logical data and the physical data. So let's see what do you mean by logical data and the physical data. Before that, we will see the basic architecture of DBMS. So what is that? We have seen a last lecture. There is 4 layer. Okay. So this layer is database layer. This is your physical layer, this is your logical layer, and this is your view layer, or this level is also called as user level. Okay, this is how DBMS architecture looks like. Okay, so this is a simple architecture of DBMS. Okay, first is database, second is physical layer. Physical layer is also called as internal schema. Next is logical layer. Logical layer also called as conceptual level. And last one is the view level, that is user level. Okay, this is your user level. Now what do you mean by logical data independency? Let me see. Whatever the stored information is there, this stores information about how data is going to manage inside. So it will work on a managing the data, means stores information how data is managed. So how the data is going to manage inside. So what is the work of a logical data independence? Is storing information about how data is going to be managed inside. Okay, next thing is what? These levels have the ability to change the logical schema without changing the external schema. Means logical data can change without changing in the physical layer, or we can say external layer. So it's having ability to change logical schema. Now what do you mean by schema? Schema is an description of a database. Okay, it is description of a database. Schema means description of a database. What is ability to change logical schema without changing the external or application program. Okay, external means physical data. That logical data is also called as conceptual data, also called as conceptual, also called conceptual, as well as internal data. Okay, so if there is any change in the logical data, there is no effect on a physical data. Okay, let's see what do you mean by physical data independency. In there, the changes, what it having the ability to change the physical data without changing the logical data or the external data. Okay, it's having ability to change the physical data without changing the logical data. Okay, so it is having, if you are going to change any changes in the physical layer, it doesn't affect to a logical layer, as their layers are independent. Okay, so first point is what? Ability to change the physical data without changing the logical data. It is also, sorry, this is external, okay, external data. So this physical is also called as internal schema. Schema means what? Description of a database. Okay. So suppose example, we will take one example. If you want to change in internal schema, okay, if you want to change in internal schema, like if you want to organize some files, different file you want to organize. Suppose you want to change the structure, or if you want to change the internal storage, or if you want to give the indexing. So all these are possible without affecting the logical data. If you want to change some internal schemas like file organization, or changing in the structure, or some internal storage, or some indexing, so this is possible without any change in a physical layer. Okay, it is possible without changing or without affecting or changing in logical layer or logical schema. Understood? So sorry, if there is any changes happen in the internal schema, it is possible without affecting the logical schema. Understood? So there is two type, that is logical data independency and physical data independency. Logical means changing in the logical layer. Okay, it do not change in a disk on any other form, it is change in on the other lower layer, it doesn't have a affect on a upper layer. Okay, similarly in physical data independency, if you change any internal schema, it doesn't affect on a logical schema. Understood what do you mean by data independency and their types? So data independence is simple capacity, it is a capacity to change the schema without affecting the other data. Okay, thank you.